All right, this past week during our robotics class at UW-Fond du Lac, we learned about sensors. Now, sensors are really important to the tasks that our robot is going to be expected to complete. Without the sensors, you're not going to know where you're at on the field, and it's going to be really hard to accomplish anything. So, let's take a look at this again. I know a lot of you are a little confused by this whole thing, but that's okay. This is all new to you. So that's all right, and hopefully watching this video will help you in that regard. So I've got my RoboBlocks up here, and I've got my robot connected, as you can see, and I've got a sprite. I've got a cat there as my sprite. And now we are going to take a look at a new category. We did this the other day, but it's still pretty new to most of us, and that's under sensing. And we've got a couple of special blocks here that read the sensors on our robot. There's this one. This one updates whatever sensor is on whatever pin is selected. And you can see, if I click there, I've got pin 0, 1, 2, 3, 4, 5. Now, these are the female header pins that are on your robot. So whatever is plugged into, say, pin 0 or 3 or 5, you choose that. And I'm going to choose 5 for now, because that's where I've got my line follower sensor plugged into my robot right now. I've got another block here that if I push the arrow there, it can display the information about all the different pins. And in this case, I'm going to choose pin 5. And if we put a check mark next to that, it displays out on the stage. All right, now, you can see right now my sensor pin 5 is reading a 0. That's because I haven't read it yet. I haven't updated it. Now, if I double click on this, we should see a number start coming back for pin 5, and it has. It came back as a 158, and that's with my robot kind of looking at nothing. I'm going to put something about 1/4 of an inch from my line sensor down below it and update that again a couple of times. Now you'll see that it's a 7. And if I put something black under the line sensor and update that a couple of times, you'll see it's coming back as, a 149 in this case, or something over 100. One way we can easily look at that over and over again is to put that update into a forever loop and run that loop just like that. And we can put our piece of paper that's black. So that's black, about 1/4 of an inch from my sensor right now, and that's white, about 1/4 of an inch from my sensor right now. And you can see it makes a difference as to how far away you hold that. So there's white, there's black, and you can see those values coming back from that sensor. Now we're going to use those values to try to figure out where we are on the field. Now, unfortunately, with Scratch, sending over Bluetooth and using that COM port and all that stuff, and just Scratch itself runs kind of slowly on a computer, and it doesn't work very well to use Scratch to do the actual sensing for line following anyway. Everything else we're going to do our sensing with Scratch, but with line following, I had to write some routines right in the Arduino to do the line following. And that involves these two blocks under motion. We've got this one that says line follow left side, and then we've got another one that says set up line follow. Now, the set up line follow, this is important if you want to change the speeds at which you're going to be following a line. Right now, you can see I've got my left motor at 180, my right motor at 0, which means what? It means that we're going full blast forward. But I could change those numbers to numbers that I know would slow things down going forward. Or maybe, let's say I wanted to spin around and then find a line. That would be this find line and stop. Then I would maybe make this number 0 and the other one 0, and then I'm going to spin around in a circle. And it's going to keep spinning around until it finds a line of the brightness 150. Now, if we were looking at our numbers there, we saw that maybe 150 would be a little high because some of our ratings were coming back at 130 or so. So I'm just going to say around 100 is going to be our threshold amount. That's because we know when we're on white back here, let's run this forever loop again here. When we're on white, we're way down at 7. So when we go to black, yeah, we're up over 100 easy. So we want to make sure we hit that every single time. So I'm going to change that threshold there to 100. And I'm going to change this back to my 180. So I follow a line going forward at full speed. That's fine. That usually works pretty well. Now, the Arduino is going to do this work. So if I click this now, it sends a message down to the Arduino that it wants to line follow at left speed 180, right speed 0, and make the change, either go left or go right, at brightness 100. Remember, we discussed in class how the way we follow a line is if we see the black line, we're going to turn right. If we see white, we're going to turn left. Then we're just going to kind of inch forward that way. So now if I click on this line follow left side, my robot will start. And when it sees white, it'll go left. And when it sees black, it'll go right. I don't know if you can hear my robot doing that right now, but it is. It's following along a line. And I can also take this and now say stop following, and the robot stops. Okay, so that's how we follow a line. First, we need to set it up. In most cases, my default values there of 180, 0, and I think I had it at 150. Maybe my brightness here in my office is a little bit different because of the ambient light that's around. So you might have to play with that brightness there if it's not following the line very reliably. Play with both the distance from the line and play with that brightness number there. But it should be around 100, 150 should work in every case. If I want to follow the other side of the line, I just choose right side here, and if I click that, my robot again starts going, only it's going to follow the other side of the line. Rather than the left side of the line, it's going to follow the right side of the line. All right, as long as we're here, let's talk about find line and stop. That is going to be handy when you're on the stage, and maybe you noticed in the middle of the stage there is a line that you can spin around and find, and that line is going to be pointing towards the audience, and that's something the judges are going to be looking for in the competition. Is your robot facing the audience? So you can set up your line follow in that case to spin around. Right? So if we make both our numbers zeros, that means our robot is going to spin, and we're going to execute that. And it is going to spin around until that the line sensor finds the line, and it will stop right on top of that line. You maybe would want to do it a little bit slower because it might not stop instantly at full blast like this at 0 and 0. But it is something that will work, the find line and stop. So we've got a few things under our line follow. We can follow left side of the line, right side of the line, stop following, or do the find line and stop. And you can use these commands. You can set up your line follow right before you call the line follow command. And let's say we wanted to find line and stop. Let me duplicate this. And then maybe drive forward along that line. And then we're going to need to set up our line follow a little bit different with our motor speeds. Make it 180 and 0. Okay, why don't we pause a little bit here between our find line and stop, and then go finding the line and just driving along forward. So we're going to drive along the left side of the line. So if I was to run this right now, it would spin around until it found a line, and then it would stop. Then it would wait 1 second. It's going to reset up how it follows a line. This time it's going to be not spinning. It's going to be going forward at full speed along the left side of the line. Okay, so that's how we follow a line. And if you still don't get it, maybe watch this again and and try to reabsorb this material. I know it's a little bit different, and I have to move kind of fast through this stuff. So let's dispose of this for now, and let's go back to this sensing category. And I've also got things set up. I've got a sensor set up on pin number 3. I've got another light sensor set up there. And I want to take a look at what it is doing. So I'm going to show it out on the stage here, and I'm going to forever update that. And you can see that is at 119 right now. And I've got this one mounted right behind my left wheel. And now it's at, I put white underneath it, and it goes down to 6 or 7, and then above black, that one goes way into the 200s. So we know that that one's working really well. And so we are going to use those numbers to stop at those black blocks that are around the field. And then there's one of those black blocks right before we arrive at the stage. So that's going to be real handy because we'll know that we have arrived at the stage. Let's get rid of this forever loop for now. And I'm going to pull out one of these sensor pin 3s, these roundish looking things. That is whatever number pin number 3 is at, is what value this round thing is. Let's go back here to our control, and we talked about this a little bit, these conditional statements. There's forever if, there's an if else, there's a wait until, and there's a repeat until. Let's pull out one of the most common ones here. This is called an if statement, and you're going to find this in all programming language. And in this little diamond shape thing, we're going to put a condition that needs to be true for whatever we put in here to occur. So it's going to be something on the order of if a number is greater than or equal to or less than or whatever we specify we put in here, then something else is going to occur. If this is not true, it's just going to go on and do whatever is after the if statement. Okay, so that's real common. In this case, we are going to use this repeat until conditional statement. We are going to update sensor pin 3 until it goes up above 100. Okay, so how do we make it go up above 100? Well, that's under a new category here we haven't used yet, under numbers. And here we've got blank is greater than blank. So let's do this. Let's pull this thing out, and you can see, well, it's the same shape. It looks like it's going to fit in there, and yeah, it is. So let's take sensor pin 3 and put that there. That's going to be whatever number sensor pin 3 is. And if it's greater than 100, we are going to stop reading pin 3 sensor and move on to whatever occurs next. And what would occur next? Well, I think we're going to want to stop. So the goal here is we want to follow the line on the right-hand side, we determined, because that stop block is on the left-hand side. So we're going to follow the line on the right-hand side. So we go here to motion and line follow, left side, let's go right side. Until pin number 3 is greater than 100. And then when it is, we will move on to the next block below it, and then we will stop following. Now, if I was to run this, I would line follow on the right side until my pin 3 was greater than 100. Because it's keeping on updating pin number 3, and as soon as it comes back to something more than 100, which means it must be on something black, we stop. And if I run that, it does indeed work. However, if I go and run this again, it goes right on to stop following. It doesn't follow the right side of the line at all. And the reason for that is that when we left off there, you can see our sensor pin number 3 was at 169, which is, of course, greater than 100. So as soon as it starts following the right side, it looks here, oh, it's at 169, and it stops immediately. In fact, it does it so quickly, we don't even see it happen. So we need to do a couple of things here before we start following the line on the right side. Let's go back to our sensing here. And what we want to do is update our pin 3 a few times before we start following the right side of the line. That way, it will set pin 3, whatever it is, and hopefully it's looking at something white when you're starting, it will set it to a white value and then start following the line and then look for it to be 100. So we're going to go here to Control and pull out one of these repeat block commands. And we're going to update pin 3 sensor 3 times. How about we do that? I'm sorry, let's repeat it 10 times. We're going to repeat it 10 times, read whatever it's looking at, and that goes just in an instant. You don't even see it happen. And again, because of my experience with Scratch, I know that it's good to wait a real short amount of time here, so I'm going to wait a quarter of a second right there. Now if I run this and my pin 3 sensor is looking at something white, well, then my pin 3 sensor goes down, and I don't have my robot actually on the field right now, but it will read it 3 times if it's on something white. Then it will start following the right side of the line until it sees something black. In other words, it goes over 100, and then it will stop following. All right? I am going to turn this into a subroutine by pulling out this when I receive. And I'm going to call this drive to stage. And I've got this subroutine for you on the Z drive. I am going to export this sprite. This is what I did. I'm going to export this sprite. In my case, I'm going to put it here on my desktop and call it drive to stage. And say OK. Now I have this subroutine that I will be using at least a couple of times during competition because I need to drive out to the stage to do my introduction, and I'll also need to drive out there to do my performance. So now I can find the code that I wrote before and add this code to it. So I called my code Team 2194. This is my remote control code that I wrote last week, and now I'm going to add this drive to stage to it. You can see I've got my remote control subroutines right here, and I've got a couple comments up there, so I'm all nice and neat and ready to go on my movement subroutines. And I want to import a sprite. So I'm going to go here, choose new sprite from file, right there. And I'm going to go to my desktop where I saved that one. And hopefully it's here. Boy, I've got a lot of stuff on my desktop, but there it is, drive to stage. And there it comes up. All right, but it's got that cat sprite. I don't really want that. So what I'm going to do is I'm going to drag this drive to stage to my movement subroutines. And you can see it bounces right back. But if I click on my movement subroutines now and move around a little bit, you'll see that that subroutine, there it is now in the movement subroutines. So I can go to this sprite, which I don't need now because it's in my movement subroutines, and I'm going to delete it. All right, so now drive to stage is one of my movement subroutines. Okay, one more thing. There was one more sensor that we're going to hook up, and this is a light sensor. There are going to be 2 lights on the field, one down near the roller coaster and one near the Ferris wheel. And you've been given the LDR sensor, or the light-dependent resistor sensor, that sees the spectrum of light that a light or a flashlight might be, or the lights that are on our field. It sees visible light. And I put that on my robot anyway in pin 0. Pin 0. And I want to show that out on the stage here. Pin 0, and I'm going to, again, a forever loop here to update my pin 0. And I am holding my LDR sensor right now in my hand, and I'm going to shine a light at it. And we see, oh, look at that. It goes way down. And if I hold the light a little farther away, the number starts going up, 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 up. And as I get closer, 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 the number changes. And it has a lot to do with the angle and so forth that the light is at. So you're going to want to keep that LDR sensor at a real steady place on your robot. But you can see that depending on where I put this LDR and its relationship to the distance from the light, that number changes. And we're going to use that number to figure out where we are on the field. And it's pretty accurate as to how far away from the light it is. So the different numbers correspond to different distances, and your challenge is going to be to find out what number that is going to be when you are at the spot you want to be near the Ferris wheel and near the roller coaster. I'm going to stop my forever loop here. But let's say I figured out that to be near where I wanted to be on the roller coaster, it's at about 105. Well, I'm sorry, if it's at about 40. I could use a real similar subroutine to this to follow the line out until my remote sensor pin 0 is at, what, about 40, I thought would be the number that I would need to stop at. So what I would do is maybe copy this whole stack of blocks, make a new subroutine for it, call it drive to coaster or something like that. And instead of updating pin 3, I'm going to update pin 0. And I maybe want to follow right side or left side. I'm not sure. I'd have to look and see which is going to make sense, but I can follow the line. And then I can say when the sensor on pin 0 is greater than 40. Oh, we want to be looking for less than 40. We can right-click that and change it to less than, and let's say make that 40. Let's say we are looking at pin 0 in this case, and make that a 40. That is going to keep following, in this case, the right side of the line until pin 0 goes less than 40. I'm going to change this back because this is my subroutine for following the line. That was at pin 3, and this was at 100, and we know that works, so I don't want to change that. That would be if you were to copy this whole stack. So you need to find out what number your LDR sensor is at when it's at the right distance from the light to be where you want it to be. And you're going to modify this whole stack, and it's going to work. It's going to stop at almost exactly the same spot every single time, out by the roller coaster and over by the Ferris wheel. So I know this is kind of confusing stuff. Once you get into it, once you get moving on it, I think it's going to simplify a little bit. And we will see you next time at Robotics.